Okay folks, so in this video I'm going to show you how to do a stem and leaf plot. This is another one of our videos on presenting data, and this is a useful one regarding statistics questions. And when you're given a statistics question in past papers, exams, they're generally always either a bar chart, maybe, or a histogram, or a stem and leaf plot. It's usually one of the other of those two types of graphs, okay? So it is important that we know these. Personally, I prefer stem and leaf plots. They're one of my favorite ways to present data, which sounds weird, but it's because there's actually a lot we can do with them. They can make the question a lot easier to solve, and we can solve a lot of calculations directly from our graph. Okay, so how we do our stem and leaf plot? Well, first let's look at it. Okay, we have our range of data here. This is taken from 2014 paper 2 question 5 ordinary level paper. I can't even remember what this was. I think it was like class tests or something like that. It doesn't matter. Okay, so we got a range of values here. Okay, and what you do is you look, okay, what's the smallest number in my range of values? The smallest number that I can see here is 8. And what's the largest number in my range of values? It appears to be 49. So what we do is we create the stem of our graph, drawing a vertical line with numbers 0, 1, 2, 3, 4. Now these numbers here represents our units of 10. Okay, so we'll see what that means in a second, but actually let's give an example here. 20. Okay, 20 is 2 tens and 0 units. The numbers to the right of the line are going to be your units. The numbers to the left of the line are your tens. So 20 is 2 tens and 0 units. So I'd put a 0 here. Now always when you've drawn one in your exam, there's all cross them out. Okay. The other really important thing to note here is when we're doing these, don't just randomly throw them down. Always try to do them in order as much as you can. Okay. Like do not do a stem and leaf plot that's not in order, because then you'll have to go back and do it again in order to do the rest of the question. So you've just wasted a load of time. Okay, so how we fit it in is, as I said, as follows. We're going through it. We're looking for the smallest number. The smallest number here is 8. Well, the number 8, how many tens are in the number 8? 0. So it's going to be in the top row, 0 tens and 8 units. Then going across again, there's another 8. Okay, so we put in our comma and we put in 8. All right, then we go again. We have a 9. 0 tens and 9 units. And that's it. There's no number smaller than 8, 7 or less. There's no and any number greater than 9, we're getting into the tens. Okay, so let's look. What's the next biggest number that we have in our set of data? It's this number here, 12. So 12 is 1 10 and 2 units. So we have our 1 10 and our 2 units. So 10 and 2 is 12. Do we have any more 12s? No, but we do have 15. So that's 1 and 5 is 15. 1 10 and 5 units. We have another 15. We have another 15. Okay. We have 16. We have 17. Do we have an 18? Yes. I should have been checking if we to 17 first, but I knew we didn't. Do we have any more 18s? No. Do we have a 19? Yes. And now we're on to the 20s. Okay, I already did 20. Do we have any more 20s? No. Do we have a 21? We have a 21 here. Do we have any more 21s? No. 22 we have. Is there any more 22s? No. What's our next biggest one? 24. And you see how when I'm crossing them out, it's getting much quicker and easier to do. 26. And we're out of the 20s. Now into the 30s. There's a 30 there. So 3 tens, 0 units. And we have, oh damn, I made a mistake. There's a 23. So just squeeze that in there. Okay, this is what you have to be careful of, okay? But I'm glad that I actually did that now, so you can see, well, what do we do? I didn't plan that mistake. That was a genuine mistake. So they're admitted to 23, so we squeeze in. You don't stick it in the end, as I said. Always make sure you put them in order, which is why I was actually leaving this bit of a gap between my numbers, was in case I did make a mistake like that, okay? So I can squeeze it in. So we have our 23. Now, do you have any 31s? No, there's a 32 though. And is there any other 30s? No, and we have 49. And there we go. So there's your stem and leaf plot. Now the other thing you have to note is whenever you're doing a stem and leaf plot, you always need to include the key. The key is your instruction on how we read these, okay? So in this question here in the 2014 paper, they had a partially written key of 1 with a line and a 6 equals, well, that's 110 and 6 units is 16. If you don't include your key, you lose marks. If they haven't given you a key like this, you need to write in on the bottom of your graph. So you have your box grid, you draw your line. They might give you this already, they might not. If they haven't, you just got your box grid of paper, draw your line, fill it in, and on the bottom, writing by hand key, and give an example like this. 1 line 6 equals 16, 2 line 7 equals 27, 0 line 5 equals 5, okay? That's what you always have to include your key, okay? So now, this is the great thing. Okay, a couple of things about this, okay? One of the first great things about this is, if I turn my stem and leaf plot on its side, oh my God, I have a bar chart. Okay, but seriously, okay, we basically now have a bar chart, and we can get the shape of our curve. It's not quite a perfect normal distribution. It's a bit higher at the start and tails off a little bit, but it's still pretty good. Okay, it's actually still a pretty good distribution. If this column were more equal in size, I'd be saying, yeah, it's a very normal distribution. And even at this, it's quite a normal distribution. If I had one big column, if this was the largest column and then it was going down, then it would be left skewed, tailing to the right. If there was a big column here and this was low, it'd be right skewed, tailing to the left, okay? But this is a fairly normal bell shape, okay? So it's a normal distribution, all right? Now, next thing we're asked is to get the range. Range is your biggest minus your smallest. So this is why stem and leaf plots are great. Looking at this, I straight away know this is my biggest number, 49. This is my smallest number, 0, 8. But we don't write 8 as 0, 8, we just write it as 8. So the range is 41. So this is the great thing. If this wasn't in order, I would need to go through this and do the whole thing again and put them in order. Okay? So that's what's great about this. Okay? Mode is your most common occurring. Okay, so which number appears the most? We have 2 8s, okay, but we have 3 15s, 1, 2, 3 15s. I don't see any more. Yeah, so 15 is the mode. Now, mean, which is the sum total of our values divided by n, which is the number of values, okay? So we need to do this. So let's make sure we don't make any mistakes. 8 plus 9 plus 2. No, it's not 2, folks. It's 12. 12 plus 15 plus 15 plus 15 plus 16 plus 17 plus 18 plus 19 plus 20 plus 21 plus 22 plus 23 plus 24 plus... Is there 25? No, there's a 26. 26 plus 30 plus 32 plus 49 equals 399 divided by n is the number of values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Divided by 20 equals. Is 19.95 here? No, but that's the thing about mean. Remember, I've said these before. Mean and median can give you a value that's not from your data set, okay? Now, for the median, it is the middle term when in order, okay? So, we have 20 values here. So so because we have an even number of numbers, there is no one middle number in here. There's actually 2. Okay. So if we were to start lightly shading these off, okay, from the 2 ends, you don't need to do it like this, but sometimes students need this to visualize. Okay. I'd be just counting, but to show you how I'd get this. Okay. So you see, I'm just at each end, I'm just lightly crossing them out so that we can. And I made a mistake somewhere, okay. But anyway, so basically what we want is the 10th and 11th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, okay. So if this was an odd number of numbers, there would be one number in the middle here. But because it's an even number of numbers, there's actually two numbers in the middle here. So it's 18 plus 19 and we get the average of those two divided by 2. So 18 plus 19, okay, is 37, divided by 2 is 18.5. Or the number that's half between. So there is our median. Okay, so this is a basic rundown of a simple stem and leaf plot. You can see now why I like them. They visually display the graph in a nice, clear and easy way to read. We still retain each individual data value in this, similar to the line plots where you have the x's, okay? But we have the actual numbers, okay? So that's good. When we turn it sideways, we can get the shape of our distribution. Is it a normal distribution or not? Because it looks kind of like a bar chart. And from just this graph, we can straight away calculate range and then our three measures of centrality: mode, mean, and median. Okay, we can measure spread, range, and in a later video, I'll be showing interquartile range as well. So that's why these are really great. If you get one of these as a question, be very happy because they're very straightforward. You can do a lot of really good work with them that you can be sure to get full marks on. Okay, so thanks a lot, everybody. Hope these are helping. Keep up the good work, and I'll talk to you soon. Bye.